All right, moving on to chapter 12 here, and we're looking at our circles. So this whole chapter is going to be about properties of circles and different things that we can do with them. Chords, arcs, anything like that. So we're going to start off with talking about what tangent lines are. So, and some of the properties of tangent lines. Okay, so tangent lines. So when we're talking about tangent lines, we're not talking specifically with what we've done in trig with tangents. Okay, they are related. Which is the tangent of a angle is basically the length of the tangent line that comes off of it. But we're looking at more of just a line itself. So tangent is tangent of a circle would be a line that touches a circle at only one point. Okay, so only one point it would touch it, and that point is called your point of tangency. And a way to help you kind of remember with tangents, it's kind of like if you ever hear someone say, "Oh, they're going off on a tangent." Basically, they're going off in some direction away from what they're talking about. So if we're talking about, let's say we're talking about math, and we're talking about math, and we're talking about math, and it's over and over and over again, what ends up happening is that if we get off topic, oh, now I want to talk about baseball, or I want to talk about what we did on Friday, what ended up happening is that we're now going off onto a tangent. We're going away from where our conversation was. And there was some point where we went off that, and that is your point of tangency. So here's your tangent line. That green line is your tangent line, and that blue point right here is your point of tangency. Okay, so it touches that one. If it touches that more than one point, it's not a tangent line. Okay, so some of the properties, some of the things that tangents have, some of the theorems and different things. So if a tangent line if a line is a tangent to a circle, so if you have a tangent line on a circle, then the line is perpendicular to the radius, okay, drawn to the point of tangency. So if I have any type of circle, and I draw a tangent line of it, and then I draw the radius from that point of tangency, it will always be 90 degrees. Now, one thing nice with this is that you end up creating right triangles to help you find different pieces, okay? But the radius will always be 90 degrees to the point of tangency. Okay, always, 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 always. And that's what this is saying, is that line AB, the tangent, is perpendicular to segment CP at point P, obviously. So let's say we have this, and we want to, and the two green lines are tangent lines, and that's an angle of 110 inside the circle, so that's central angle. And this is our center, obvi. And we want to find the measure of x. So take a second, see if you can figure out what the measure of x is. All right. Well, hopefully you figured out that, hey, if these are tangent lines to green lines, that means that these have to be 90 degrees. And if those are 90 degrees, that means that I've got a 90, a 110, and a 90 in a quadrilateral, a four-sided figure, which needs to equal 360, which means that my measure must be 70 degrees. Okay, so it would be 70 degrees as my answer because those radii crossing at the tangents make 90-degree angles. Okay. All right. So use this one. Take a second. Solve for P. And again, that's going to be the center. We're assuming it's the center. So the orange one is our radius, green is our tangent. So P is inside this triangle. This is a right triangle, which means that P must be 65 degrees. Because 65 plus 25 get us 90, plus 90 equals 180 degrees. Okay. All right. Okay, so now let's say we have, you can think of this kind of like a bicycle chain. Okay, so you've got two circles on a bicycle. You have multiple different gears, but you have the one right by your foot and then the one back at the pedal, or not the pedal, at the wheel. And what you have is that chain. And what we want to do is we want to find how far apart these two centers are. Okay, so take a minute and see if you can find it. That's a tangent line. That's 50 feet from point of tangency to point of tangency, and the radii are 15 and 10. So take a minute to find the distance between A and B. Answer's not 50. Okay, so basically what ends up happening here is we've created kind of a we want to find this length down here, that red line I just drew. And so what would happen is, since we know that this has to be 90 degrees, okay, what we're going to do is we're basically going to take this green line and we're going to shift it down. And that green line, let me draw a green line, that green line is now going to go from B up there. This is now 50, this is 90 degrees, and this is 5. Because this length was 15, this length was 10, the difference would have been 5. So now we have a triangle, a right triangle. One side's 50, the other side's 5. And now we can just use Pythagorean theorem to help us find it, which ends up getting us 50 feet, 50.25 feet approximately. Okay, so 50.25 feet ends up being it because it's 50 squared plus 5 squared equals c squared. Okay, so it's just a right triangle. So this one you would see it's, you kind of have to manipulate it, you have to kind of shift it down, but it ends up being a longer number. Okay. Okay, next property. If a line in a plane of a circle is perpendicular to the radius, then it must be the tangent. So this is just doing the converse of it. So this is just taking it and flipping that if-then statement around. So if you know that it's a right angle between the radius and a line, okay, that is touching at only one point, then that line must be a tangent of it. Okay, it must be a tangent of it. Okay. So again, this is just reversing what we've done before. So if we look at this one, we're asked, is this a tangent? Yes or no? And this one, since if the green line down here with this 7, if that is a tangent, that means that it must create a 90-degree angle inside where the radius and the line meet. Well, where the radius and that line meet, we should have a right triangle. So we'd go 5 squared plus 7 squared equals 8 squared. And we'd go through and we'd solve that and see if it's true, end up seeing that it does not work. We end up seeing that it does not work. So that means that, is this a tangent or not? That means it's not a tangent. Okay. So it's not a tangent because we didn't create that right angle. It needs to be a right angle for it to be a tangent. If it doesn't have it, then it's not a tangent. It ends up being more like a secant. Okay, so now check this one. Take a minute. Find if this one is a tangent. Okay, so now with this one, you do the same thing. You set it up. 18 squared plus 24 squared equals 30 squared. Looks like you can take a 6 out of every single one, and you get a 3, 4, 5. So it does work out. Okay, so that means that, is this one a tangent? Yes, it is. Yes, it is a tangent. Okay. All right, so if two segments that are tangents to a circle, if they meet outside of the circle, what ends up happening is that the distance from the point of tangency to that point will always be congruent. So anytime you draw a circle and you draw a line, two tangents coming off of it, and the tangents meet somewhere, this segment and this segment must be congruent. They will always be congruent. So if one is 7, the other one has to be 7. If one is 12, the other one has to be 12. Okay, so that's what we have for these. That's what this one's basically stating. If our tangents meet outside of a circle, the distance from points of tangency to the point of intersection must be congruent. So let's say our perimeter here is 74, and we want to find what x is. Well, based on our points of tangency and everything, we know that this has to be 8 up to there. This has to be 2. This has to be 15. Because these are all tangents that meet outside of it. And that means this one's x. So take a second, find x. Okay. Hopefully you found out that your x was 12 inches. So it would be 12 inches for both. of the x's. Okay. All right, so here's your homework for this section.